Determine whether the integral is convergent or divergent. Evaluate if convergent. The integral from 0 to infinity x squared over the square root of 1 plus x cubed dx. This is an improper integral, which we can see by the infinite limit of integration. And so we have to use the definition to evaluate that, and that involves a limit. So this is the limit as b goes to infinity, the integral from 0 to b, x squared over the square root of 1 plus x cubed dx. Now, the integral that remains is a definite integral that the fundamental theorem of calculus applies to. So let's take it over here on the side and evaluate it. We can evaluate this integral by doing a substitution. So we can let u be 1 plus x cubed. Du is then 3x squared dx. Notice we have x squared dx in our integral, so we simply need the 3 there. So we have to multiply by 3 on the inside, divide by 3 on the outside. So now our integral becomes 1/3 the integral on the new limits of integration, 1 over the square root of u du. One over the square root of u, of course, is the same as u to the negative 1/2. The square root is the 1/2 power, and since the square root is in the denominator, we can bring it up by putting a negative in that exponent. When you integrate that, you have to add 1 to the power, so u to the negative 1/2 plus 1 is positive 1/2, and then you have to divide by that same number. And this is still a definite integral, so we have some limits of integration, though we don't know what they are in terms of u. Dividing by 1/2 is the same as multiplying by 2, so we actually have 2/3. And the 1/2 power is the square root. And u, let's see, what was u? U is equal to 1 plus x cubed. So 1 plus x cubed. And now we can go back to our original limits of integration, 0 to b. Okay, so there's our integral evaluated. So we take that back over. We have the limit as b goes to infinity. 2/3 square root of 1 plus x cubed from 0 to b. So the first thing that we do is we substitute the b in for x. That's the upper limit of integration we're substituting in. So 2/3 square root of 1 plus b cubed minus then 2/3 the square root of 1 plus 0 cubed. We put in the lower limit of integration. Now when we start taking the limit, well, first of all, we notice that 0 cubed is 0 plus 1 is 1. Square root of 1 is 1. When you take the limit of negative 2/3 times 1, you end up with negative 2/3 because that's simply a constant. However, b, remember, is going to infinity, so it's getting larger and larger. If you take a very large number and you cube it, it gets larger still. So b cubed goes to infinity. If you add 1 to that, you're still going to infinity. And even if you take the square root, then 1 plus b cubed is still getting large enough that it dominates that whole thing. So this whole thing is getting closer to infinity. Multiplying by 2/3 does very little. We're still going to infinity. So the limit of that 2/3 square root of 1 plus b cubed goes to infinity. And subtracting 2/3 does not make any change there. So our limit is infinity. That tells us that the limit diverges, which in turn tells us that the definite integral, improper integral that we started with, also diverges. So the integral from 0 to infinity, x squared over the square root of 1 plus x cubed, 0 to infinity, x squared over the square root of 1 plus x cubed dx diverges.